Hey guys, in this video lesson we would understand what is a rate law and how to determine reaction rates given the experimental data. Let's first understand what is rate law. Rate law is defined by an equation that explains the relationship among rate constant, the initial concentration of reactants, and the orders of reaction. The orders of reaction is always found out with respect to the reactants. Therefore, a rate law equation is written as R is equal to K concentration of X raised to the power M, concentration of Y raised to the power N. Now, X and Y are the reactants. So, if we have an equation like this, X plus Y gives us XY. So the reactants we have is X and Y. We always take the concentration of the reactants raised to the power of their orders. M and N are orders of the reaction. These orders are nowhere to be seen on the reaction. They are always determined experimentally. Now here lowercase r represents the rate, K represents the rate constant, X and Y together are the reactants. We know when we put a square bracket around anything, that's called concentration. So this is concentration of X. This means concentration of Y, and M and N we already described. They are the orders of the reaction. Always remember rate is affected by rate constant, it's affected by X concentration, Y concentration, or we can say it's affected by the concentration of the reactants, and it is also affected by what is the order on the reactants. Let's say if we're given an equation like this, rate is equal to K, X to the power 1, concentration of Y is raised to the power 2, and there is another reactant, concentration of Z to the power 0. How do we explain this? We say rate is dependent upon the rate constant. We say that rate is also dependent upon the concentration of X raised to the power of the order of 1. Rate is dependent upon the concentration of Y raised to the power of order 2, and rate is dependent upon the concentration of Z raised to the power of 0. Now what do these orders mean individually? This means that if the concentration of X is doubled, because X has a power 1, the rate of the reaction will be doubled. So remember, if the power is 1, that means the order is 1, then whatever happens to the concentration of that particular reactant, the same thing would happen to the rate as well. So we can summarize it like this. If order is 1, whatever happens to reactant concentration, same happens to the rate. Let's describe Y concentration to the power of 2. So if concentration of Y is doubled, because we see Y is raised to the power 2, and if Y is doubled, 2 to the power 2 is 4, rate is going to become 4 times, which is also called quadrupled. So rate becomes, or rate gets quadrupled. Similarly, if concentration of Y is tripled, rate gets, or rate becomes 9 times. Why is that so? Because the power is 2, and we know 3 to the power of 2 is 9. So we can describe it like this, that if the order is 2, whatever happens to the reactant concentration, it results in the squaring of the rate. Now let's describe Z. We know Z was to the power of 0. So if Z concentration is doubled, means if initially it was 1 and now it has become 2, because the power is 0 and now also it's power 0, the result is always same, because anything raised to the power 0 is 1. So if the concentration of Z is doubled, rate stays unchanged. Therefore we can conclude that if order is 0, whatever happens to the reactant concentration does not affect the rate of reaction. So this is how we describe what happens to the rate when the orders change. Let's understand this with examples, and let's take up the first question. Let's read the question first. 2N2O5 giving us 2NO2 plus O2 is a reaction where decomposition of dinitrogen pentoxide is happening, and this reaction is a first order reaction with respect to N2O5, that is dinitrogen pentoxide. If the initial rate of consumption, so first let's write this down into a rate law equation. We know rate is equal to the constant multiplied by the concentration of the reactants, and here we just have one reactants, N2O5, raised to the power of its order. We are given the question, it's a first order reaction, so we would put in 1 as a power. If the initial rate of consumption is this, so we are given the value of R, 2.1 times 10 to the power negative 4. The reason they have given the word consumption is because it's a reactant, and reactant gets consumed in a reaction. So rate of consumption is moles per liter second, when the initial concentration of N2O5 is given to us as 0.40 moles per liter. So the concentration of N2O5 is 0.40 moles per liter. Predict what would be its rate if another experiment is performed with initial concentration of N2O5 of this. Now we are given this in a reaction and we are given this in the reaction. We already know the order. What we do not know is the constant. We would put in all of this information into the reaction to find out the constant first. So we get 2.1 times 10 to the power negative 4 equal to K, and the concentration of this is given to us is 0.40 raised to the power 1. We are looking for K, so we would isolate K. 2.1 times 10 to the power negative 4 divided by 0.40, and we get 5.25 times 10 to the power negative 4. And the units we work as, so this is moles per liter second. Here we have is moles per liter. So this liter goes up. Liter gets cancelled, mole gets cancelled. We are left with this number per second. Now always remember, for a particular reaction, the constant does not change. So we would have the constant as 5.25 times 10 to the power negative 4. All we would have to do is, now we would put in this K value and we would put in the new initial concentration of N2O5 as 0.80 and we see what rate we get. So the new rate is going to be equal to 5.25 times 10 to the power negative 4. Concentration mu is 0.80. When we multiply this, we would get 4.2 times 10 to the power negative 4 moles per liter second. So this is what we have got. Now we would compare something here. We notice here that the concentration of dinitrogen pentoxide initially was 0.40 and later the concentration was doubled. When the concentration is doubled, we know that if the order is 1, then the rate of the reaction also needs to be doubled. So let's see whether we have got a doubled rate of reaction or not. This is our initial rate of reaction. This is our new rate of reaction. When we compare both of these rate of reactions, we see that this rate of reaction is double of this. Even if we did not do all of this and we would have just noticed that the concentration is doubled, so the rate would get doubled, that would also have given us the right answer. Let's take up another question for the sake of practice. Let's read and understand this question first. The question says, 2NO reacts with chlorine to give 2NOCl. Initial rates of reactions are determined for various combinations of initial concentrations of the reactants. We have two reactants, NO and Cl2, and the result is recorded in this table. So there were 3 trials done where the initial concentration of NO was recorded to be 0.10 and the initial concentration of chlorine was recorded to be 0.10. Units are moles per liter for both. Rate of production of NOCl, because NOCl is a product, so the rate of reaction is represented as rate of production. Unit is moles per liter second, and the value is 1.8 times 10 to the power negative 2, so as the other trial values are listed. Now what do we have to determine from here is, the first thing that we have to determine is what is the rate law of the reaction. We know the general rate law equation is R equal to K. Here the concentrations are specifically for NO and Cl2. So we would put in NO here and we would put in Cl2 here, raised to the power of M and N. M and N are determined experimentally, so that means this is what we have to figure out from the experimental data or from the table given. How do we determine what is M and N? Now to determine the orders, we would have to look at the initial concentrations of the reactants and compare them with the rate of production of NOCl. If we want to determine M, we know M is the order of NO, so we would check in the table where is Cl2 constant. We are looking for the concentration where the Cl2 is constant because we do not want to affect Cl2 in determination of M, as M is just the order of NO. We see that trial 2 and trial 3, Cl2 or chlorine concentration is exactly similar. Now we do not have to look at this at all because chlorine is not affecting the rate at all, as the concentration of chlorine is exactly same. We'll look at nitrogen oxide concentration. We see in trial 2, nitrogen oxide concentration is 0.10. In trial 3, nitrogen oxide concentration is 0.20. And when it goes from trial 2 to trial 3, it becomes double. Now we would compare this to this. What happens to the rate when the concentration of nitrogen oxide is doubling up. To compare this, we can take the rate of trial 3 and rate of trial 2 and divide them. We would notice that when we divide the third trial of rate of NaCl with the second trial of rate of NaCl, that is 1.43 times 10 to the power negative 1 and 3.6 times 10 to the power negative 2. The result that we get is approximately 3.97, which is 4. So we can see that when this doubles up, this becomes almost 4 times. So when the concentration of the reactant doubles up and the rate becomes 4 times, that means your M value is 2. So the order of the concentration of nitrogen oxide is 2. Let's work on chlorine and find out what is the order of N. Let's work on chlorine and determine what is the value of N, or the order of chlorine. Now when we have to determine the order of chlorine, we need to make sure that the nitrogen oxide does not interfere. So we would see where is nitrogen oxide concentration constant. And trial 1 and trial 2, we see the nitrogen oxide concentration does not change. So let's compare trial 1 and trial 2 for chlorine. Trial 1, trial 2, we notice that chlorine concentration has doubled up, and here we want to find out how the rate has changed. When we divide the second trial rate with the first trial rate, that is 3.6 times 10 to the power negative 2 and 1.8 times 10 to the power negative 2, we would notice that the result is 2. So this also becomes 2 times, or this also doubles. If this becomes 2 times, this also becomes 2 times. That means if this doubles up, this doubles up. So from here we figure out that N is 1. And why is that so? Because if chlorine concentration doubles up, rate also doubles up at the same rate also doubles up. So rate has the same effect as the concentration of chlorine changes. Therefore the power is supposed to be 1. So what is the rate law equation? R is equal to K, concentration of NO raised to the power of 2, concentration of Cl2 raised to the power of 1. Next part is calculate the value of rate constant. Going back to the rate law equation, we know rate constant is K. So if we want to determine the value of K, we would have to isolate K. That would make our reaction look like R divided by concentration of NO raised to the power 2 multiplied by concentration of Cl2 raised to the power of 1. Now to pick these values up, R, NO concentration and Cl2 concentration, you would have to go back to the table and we can pick up any one of the trials for all of these 3 values. Make sure that you pick up only the same trial for all 3 values. You cannot pick up NO concentration from trial 1, Cl2 concentration from trial 2 and rate concentration from trial 3. That is a completely no-no. Same trial for all the 3 values. So let's say we pick trial 1. We put in NO concentration as 0.10, Cl2 concentration as 0.10, and the rate as 1.8 times 10 to the power negative 2. So rate is 1.8 times 10 to the power negative 2. NO concentration is 0.10 raised to the power of 2. Cl2 concentration is 0.10 raised to the power of 1 this time. And when we put this all on the calculator, we would get 1.8 times 10 to the power negative 2 moles per liter second. Now we have found this by using 2 different concentrations. One is for NO and one is for chlorine. NO has been raised to the power 2 times. So the unit for NO, that is moles per liter, will be also squared up. Now for Cl, the power is just 1. Similarly, for Cl, the units will be written just 1 time. We would cancel whatever gets cancelled out, moles with moles, and finally we are left with 18 liters square per second mole square. This is what we get the value for K with the units. Next part of the question wants us to calculate the expected rate of reaction if the initial concentration of NO and Cl2 were 0.30 and 0.40 moles per liter respectively. How do we solve this? We know rate law is R equal to K NO raised to the power 2 Cl2 raised to the power of 1. Now K for a particular question is always going to stay the same. We know here the K that we have got in the previous part was 18, and it is 18 liters square per second mole square. Concentration of NO that we are given is 0.30. So we would multiply this by 0.30 moles per liter square, and we would multiply this with 0.40 moles per liter. Power is just 1. When we put these numbers in the calculator, 18 multiplied by 0.3 square multiplied by 0.40, we get 0.648. And let's work with the units now. We have liter square over second times mole square. We have mole square over liter square, and we have moles per liter. So we would cancel mole square, liter square. And here we just noticed that we are left with 0.648 moles per liter second, because we were left with this, we were left with this, and we were left with this. And that is what is the unit of a rate. So this is how we solve a rate problem when we are given experimental values.